So our goal today, or shall I say right now, is to implement, whoops, that's not what I wanted to do, is to implement gates. So let's add a new mode to the tool, which I'll call gate. Let's just make sure that does the right thing. Yeah, so for right now, gate and erase do the same thing, but we are going to change that. Now, state bars for gates. Last, so we'll keep track of the last negator state. So negator, or well, last, I'm thinking about it, gate variant will start out as 0, and we will have gate cell mode is false. So the idea is, in the main loop, if this G cell, I'll just call it G cell, if this G cell is true, yeah, if this G cell is true, we'll draw like a gate select menu, and this GT var will be the select index. Yeah. So let's make it's kind of annoying to move, like, because if I want to take this tab and put it here, you can't, but oh, whatever, let's just and then here I want to call this drawing functions. Uh-oh. Yeah, okay. Uh-oh. Oh no. Okay, we have some undoing to do. Abort. Okay. And I want this to become drawing functions. And I guess we just lost old, but that's okay. I didn't really need it anyway. So let's grab this. Oops. put it here. I kind of want a tab for helper functions and that's where I'll put DFS. I mean, let's just do it while we're in the middle of like organizing things. And then here, helper functions. Alright, let's just make sure this actually still runs. I've had this annoying like tickle in my throat now for a couple days. When I start talking, I start coughing for some reason. Anyway, okay, so this is still working. Yeah, I was thinking about this yesterday night while I was trying to sleep. I'm not going down this road anymore. I'll leave it in case I change my mind, but yeah, we can get rid of this and not using that. And okay. So now let's go in here and we will add a draw gate select. Jeez. Alright, I think get some water. All right. So, I guess we will draw a little box. This will just put it Why am I coughing so much? Okay. So it would be nice if it didn't obscure where you're currently drawing so that you can like see what you're doing. So how big does this box need to be? We need to draw 16 gates. I guess we'll draw them in red. We can draw them in a 4x4 pattern, I guess. That'll be kind of nice. So that means we need, and I'll space them out a little bit. So for each one, I will need the 8 pixels it currently takes, plus 1, plus 2. Let's do 2, so it's 10. So that's 40 pixels. 40 by 40 pixels, and I guess I'll just pick a quadrant. So TLX, TLY is, let's just start it out at 4, 4. If the cursor is less than 64, oh God, what is going on with me today? Okay, so to this we will add, or we'll just do TLX equals let me think about this. I guess I want it lined up with the corner, so it'll be 127 minus 4 minus 42, which I may as well just write like this. The width of the box is going to be 42 in total, because I'm going to have a 1 pixel border around the outside. Okay. So now we will do rect TLX, TLY, TLX plus 41, I think. TLY plus 41. And I want it to have a dark border, and rect fill. TLY plus 1, TLX plus 40. I guess I can do it like this. I really wish the rect was width height instead of X and Y bounds, but whatever. And I want this to have a white background. Let's just do this right now so we can see what it looks like. Oh, fine. This will clash with the text, so let's do 8, 8. Do like that. Okay, and then let's just do this for now so we can see it. Okay. Well, that. Oh, no, not less than. Greater than, and not 64. Should be 8. Well, we'll do greater than or equal. I think I got it backwards. No, I had it right the first time. Yeah, it's less than. That's pretty good. Yeah. Yeah, I think that's all right. And now The next thing to do is draw all the tiles. In what order shall we draw them? Let's have a. It would be nice to draw them in like a. You know, so. So like these four come as a group, just the single negators, and these four come as a group, the double negators, and these four come as a group, and then you know by default the other four make a group. So I'll just call this maybe this should be a global. Well, I mean it's going to be a global, but maybe I should put it here. I'll just call it gate order. Oh, I know what to call this, G menu, that's way better. And then this can actually be the gate cell. And we will call this G menu. And then here I'll draw a special cursor for selecting. It should be a different color. What? Let's just make it do this. So it just covers all of the blank space. And we'll also do a little hack here so that doesn't show this extra edge because this will be a little trick. How's the contrast against the whites? Yeah, that's pretty good. Yeah, I like this. Okay, this is tile number 10. Okay. Excuse me. So, oh yeah, that's right. I was in the middle of doing this G gourd. And I just remembered one of my scout leaders from when I was a kid. He was a cool guy. His name was Gord. Anyway, moving on. So on the top row, I will have the nothing, the 2 straight throughs, and the everything. So that is 64, and then 78 through 79. 77 through 79? Wait. Yeah, 77 through 79. And then after this, I think it's just in order. And then here we will do actually, I mean, why not just do this? Okay. And we will do for I equals 1 to 4 do, for j equals 1 to 4 do, now we will do sprite, Gord of ij, we will put it at TLX plus 2 plus 4 times j, except j minus 1, so we'll do like this. And then TLY minus 2 plus 4 times I. Alright, let's see what this looks like. Oop. Oh, yeah. Well, that's not quite right. Oh, duh, 8. Okay, no, 10, 10. Yeah, there we go. And then, finally, we will do sprite number 10, special gate cell cursor of TLX minus 8 plus 10 times, what do I call it? Just G cell X and Y? Yeah, G cell X and Y. With an underscore? No, no underscore. Minus 8 plus 10 times G cell Y. Doopy doopy doo, bitty 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 dee doo, beep bitty dee doo, bitty 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 dee dee doo. Hmm. Well, this little trick of hiding the bar did not really work in my favor there. Alright, let's just edit this. Yeah, actually I think that's better. Although the color could be... I think the color needs to be different. I think purple would work, since in the gate select menu it's always... No, because we do have some purple in there. Maybe the dark green would be nice? No, because the negators are green. Let me look at it for inspiration here. No. I mean, the blue is still kind of looking like the best option. Definitely not that. The dark blue might not be bad, given that there's going to be white in behind. Honestly, I think it's fine with just the blue. So... yeah, it's fine. We could even pull back on this. The blue against the red like that and just the dots is, for some reason, not working. I do like the dots filled in. I just need a better color. Maybe purple would work, actually. Whoops. I just leave it as blue. Okay. So now over here in the update, so if G menu, then blah else blah. I mean, this is kind of dumb, but you know, we really don't need to be. Yeah, actually, we do need to do this. Whoops, not there. I'm mixing 0 indexing and 1 indexing in my code here. Oh yeah, the blue really doesn't work in the dots. Especially not against the green. So yeah, this is gonna go away. Actually, the blue just doesn't look that good against the green. What if I just draw the ordinary cursor? Yeah, this has the advantage of, you know, matching what we're doing. And then actually what we could do in here is we could actually make, okay. Here's an idea. We could make this like a darker blue. And we'll use this in place. Yeah, so now in here what we can do, where am I drawing the cursor? G menu and 10 or 1. Kind of dumb, but you know, gets the job done. I don't like the color. No, I definitely can't do that. Actually, that's pretty good. So the blue is the active one. Okay. Now, now we will do else if mode equals 2, then we'll do this for now. So we're doing this, you know, we draw some wire and we say, oh, you know, I want to put a gate right here. So you go to the gate tool. Okay, the fact that it goes crazy like that means I need to do something about it. Then we leave here. Okay. Else if 3. Oh, not x, x. So you draw some wire. And you're like, ooh, I want a gate. You pick a gate, and you're off to the races. Okay. So if not G menu, then G menu equals true, else we will place gate. Which we can just write it inline here, I think. You know what? No. Let's just do it the same way we're doing everything else. CY. And let's also do G menu equals false in here, just, you know. Okay, and then we'll do G menu equals false. So now we need this function place gate. So the first thing to do is to erase whatever's under there. So I'm going to rename this function here. Instead of being erase wire, I'll just call it erase, I don't know, square. Blank, else if cp.type is gate, then I don't want to indent this stuff down here, so delete pointers from how do I write this? For each port, follow it and disconnect. And then over here, so if net then, else if gate, we will do unimplemented net to gate. So first we will erase square of cx cy. Equals grid of L. I'll put this in to do, I'll do it later, but to do check original list of neighbors so that new gate. Oh, actually, do we really want to do that? Because right now there's no obvious way to disconnect a gate from a neighbor unless you like erase the wire that it connects to and then place the wire again. Yeah, actually, let's not do this. Then we will do grid of, so we need a new gate, so G equals type equals gate. How will we do the ports? Oh, they're running me. Let me find something else to listen to. Oh, I actually have something open already. Yeah, sure, this is fine. So I've decided that each port is simply just a pointer to whatever connects to it, and it can be nil. So ports equals blah. Except something needs to be able to point to a port, and a port needs to be able to point back to yeah, it's fine. It's fine. Port dot parent equals g g dot port and equals 1 to 4 do g dot port of I equals actually I don't know if we need this. We will do parent equals g and you know, like the connectee or I don't know, a neighbor or whatever. No. I don't even know. So this soundtrack I'm listening to, which I've listened to a lot, it just was recommended to me on YouTube one day. I have no idea. It's called like Ancient Is, like YS, Ancient Is Vanished Omen. I'd never heard of it. I don't even know what platform it's on, although I think it was probably for like PC. Let me look it up. I kind of want to. 1987. Oh wow, it was actually released on the NES as well as on the PC. I think the NES is probably a port. I should try it out. I wonder if it got a remaster. Now I'm just goofing around, but oh my goodness, they are still making these games. Oh my god. Wow, they're like big budget now and everything. All right, enough of that. Okay, what was I just doing? Oh yeah, okay. Now, for the gate, we also need to know, like the negators. So, I don't know, our variation, I guess. I guess I'll call this gourd of G cell. Did I do a D cell Y? Yeah, it goes Y first. G cell X. And from this we'll also subtract we'll subtract 64 to map it to the range 0 to 15 because we're going to use this in a lookup table. Maybe I'll call them negators, like negs. Okay. This doesn't do anything, so there's really no point in keeping it. Yeah, figured that would happen. I'll just write it down here. Connections are made. The neighbor field is set to point to Also, the gate needs a state. I guess I'll just call it 0. Nets also need a state, so we now need to do this. Zero. Yeah. And then when we draw wires, local off equals O dot state and O dot state equals 1 and 32 or 16. So now these should all be, that didn't work. Oh yeah, because I gotta do this. Now they should all be purple. Yeah. And they will go high once I connect them to things that drive them. Yeah, so gates aren't visible right now, but they exist. Yeah, anyway. So let's start drawing the gates. So here we have if net, then all of this. Else if O dot type is equal to gate, then local T node is equal to oh yeah, okay, so let's copy this. So we need 48 and 64 equals off plus O dot eggs. Is that what I called it? Well, let's just try it. And set OX plus J, OY plus I, Tino. So we put some wires in. Then we put in a gate. Let's do an AND gate. That didn't work. Am I even calling this function? I am. Oh, I am calling it, but it doesn't do anything right now. But that's okay. So now we do grid of L equals G and also add gates G. So we draw some wire and we say, hey, I want a gate. Gate, let's do an AND gate. All right, so now if I go back to the wire tool, this won't do anything. We'll also check the logs there, so. Unimplemented net to gate. Yep, that's exactly what I expected.
Uh-huh.
Now, that's interesting, actually. Let's just connect these. We should have 2 nets right now, and we do. Yeah. Yeah, because right now we can't connect anything to gates. I can erase a gate. Ooh, that didn't work. So, erase square. Yeah, okay. So now we will do for I equals 1 to 4 do P equals C dot port of I. Now we will do if P dot neighbor then there's a lot of nested ifs here. I gotta iterate through the type. So let's do a meta table here. What did I call this? Def tab or something? This will work. I think I just called it def, yeah. Which lets us write this logic a little more cleanly in here. So if p.neighbor.type equals net, then this, else if p.neighbor.type equals gate, then that. Junctions. So, I think all we need to do for nets is oh, actually, I just had a thought. I think this will also make things a little easier. So actually, this will work for junctions. By using same port struct for gates and junctions. This case covers both. So now we just do p dot neighbor equals nil. And then for the nets, we have a list of gates, which I guess we'll do as a set. So we'll simply do p dot neighbor dot gates of p equals nil. I think that's all we need. And after we do that, now erase it on map and gates list. Let me make sure I'm using del properly. Yeah, okay. So the ports are always non-nil, I think, when I create them, right? Yeah, the ports are always non-nil. I just realized something. For these gates, the ones with negators on the output, the internal state of the gate is actually going to refer to this here, not to that. So actually, I need this is going to complicate the gate selecting screen. Let's just try it out and see what happens. Oh, but we can do a really nasty trick. 1, 2, 3, 4, 5, 6, 7. There should be another one. Yeah, let's just do that little nasty trick here. What am I, okay, hold on, what's going on here? Just make the gates all red. So color 2 should become color 8. Yeah, okay, good. They're all red. Good. Let's go in and fix these ones too, because the state should. I don't want, when I'm doing the simulation logic, I want to just directly write the state to the output, and when I do the computation, I don't want to have. Anyway, this will work. I'm finding it hard to explain why it'll work, but we need to swap them so that the state represent, like, so it gets drawn correctly. I don't know how to explain this. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think that's good. Okay. Now, where was I? So I have, oh yeah, let's just see if this works. Well, we may as well reset it. Okay. Now we have gates. Let's put down, I don't know, this one. We'll put down that one. Well, it's not being simulated right now. Okay, we can erase it. We can erase it. All right, let's put in some debugging here. Debug num gates equals. So bam, a bunch of this. Put in an AND gate. Let's put in another AND gate. And another AND gate. So we should have 3 gates. Now if I, oops, that's not what I meant. So now if I, now we have 4, and I erase, we still have 4. Still have 4. Okay, something's wrong. No, actually, yeah. So I think this is where, oh, it's gats, not gates. That's why. So we have this. Okay, now let's draw some gates. Whoops. Yeah, it's a little weird to connect them top to bottom like this, but, you know, whatever. So now, 5 gates, 4 gates, 3, 2, 1, 0. Okay, I think that's working. You know, this actually, this would work for junctions too. Anyway, we'll deal with junctions later. I'm not doing junctions today. I want to get the simulation working today. So the next thing I need is to connect nets to gates. Where is that? This is where things really get tricky. So this is the previous. I don't need this assert anymore. Last wire is net. Wire on gate. If last wire is net, then a bunch of logic that we're going to need, and then else we'll just do a little log statement. Log. Nothing to do. Net to gate. Now here's where we really got to think. Now we need to get the port. Find port object that aims from C to LW. So local last wire linear is going to be last wire y times grid width plus last wire x. Local D is going to be linear minus last wire linear. I think I already set up a lookup table. Yeah, right here. Well, we can just copy this. It's a little expensive to construct it every time we call the function, but this function actually gets called, it's the draw function, but it's only once per frame. Yeah, it's fine, it's fine. So let's go in here. So now here we do local, I guess, pnum lookup table. So now I really need to think about this. So if the current minus the previous is 1, it means I think it means we're to the right of it. So it's port 1. Otherwise, this means we are below it. Yeah, actually, I think this just works like that. Local pnum is equal to pnum lookup table of D, and let's also just assert that. No, actually, if pnum, then, so pnum can be nil if the last wire is far away. So now we connect net to port. So local P is equal to, I guess I'll call it port is equal to P. I'm starting to use a lot of variable names here, but anyway, this P is already the previous. P dot port pnum. So pt dot neighbor equals current, and then current dot g. Oh, did I call it dot g? I think I did. Of port equals true. So yeah, let's go back into the erase function here. Yeah, it's just called G. Okay, so now in the drawing function, we need to understand how to connect to gates, but that's pretty simple. So right here, we would also, yeah. Else if n dot type equals port. You know what? Let's just do it like this. If n equals O, or n dot type equals port and n dot neighbor equals O. So yeah, that just handles that. What's going on with my indentation? No, it's gotta be like this. All right, let's see if this works. So let's put in an AND gate, why not? Oh, that's not what I wanted. Ooh, okay. So the last wire is a net, the current is a gate. Oh. We need current. This is actually previous. Yeah, we gotta do some debugging. First, let's, in the gate dump here, oh, right, one sec, I gotta go get my phone. I am expecting some communications. Okay, now. I'm not saving the coordinate, am I? Let's just also do debug, I don't know, num ports equals okay. Num ports is 0. Let's put in a gate. Let's connect these. Num ports is still 0. Okay. So the problem is in here. Let's do log connect gate port. Log pnum equals let's do toStr because it could be nil. And then in the drawing functions, oh yeah, let's also change it to button P just to make it easier to debug. Oh yeah. Okay. So let's check the log. Try to erase blank, that's exactly what I would expect. So back to wire. Now we try to connect these. And what happens? Wire on gate. Connect gate port. Port num is wrong, but we'll fix that later. Okay, well, the fact that it's non-nil is correct, but the fact that it's 1 is not correct, so I'll deal with that in a second. But so local pt equals current, which should be the gate, dot port of pnum. Oh, I get it. I know why. Yeah, I know why. It's that set meta table. instead of this, what I need to do is neighbor equals blank. And I also need to do that in the erase wire. Gate neighbor equals blank. I think that's what I need to do. No. Okay, now what happened? Numports is still 0. Pnum equals 1. Actually, why didn't that work? Local PT, whatever, let's just log some more stuff. Yeah, so far it seems right. pt.neighbor equals previous. Numports is still 0 though, which is not correct. Oh, duh. I can't do that. Oop. Imports is 0. Whoops, that's not what I meant to do. Let's put a gate. And now we can try to wire it. Oh, and imports is 1. Alright. Maybe it's just something wrong with the drawing function. If the new equals the old, or the new is a port and n.neighbor equals old. So this is what's not working. Also, that helper, I want the helper, because the helper's not going to be visible if there's a negator, so let's quickly just put that in while I'm thinking about it. Helper stub. Minus D. LWX times 8. LWY times 8. Oh! Oh, LXY. LW. Yeah, that helps a lot, actually. So now if we put down a gate, and if we go back to wire, yeah, so that shows that we'll connect them. So yeah, the num ports goes up, which seems correct. We'll deal with erasing in a second here, but let's just get the drawing working, because for some reason the drawing isn't working. So oh wait, what's going on here? So local O is like the current. Not really sure why I called it O. I guess O for object. Then for each of the neighbors, local N is the grid plus, yeah, so N is the neighbor. If, oh, I see. If N dot gate, I see, yeah. I see. Oh, you know, we can always do this. Scan through ports to see if one connects. This is like not super efficient, but whatever. And for do, and if n dot port I dot neighbor equals O, then whoops, that's not what I meant. Oh, okay, we got a lot of this is a lot of stuff to do. Hey. Ooh, I think the merging here is not working. Let's put down a gate and let's get the heck out of the gate tool. You know what? I think after the gate tool, we'll just immediately go back to wire. Place gate G menu equals false, mode equals 1, go to wire mode. Yeah. So now the problem is that when we merge wires, we lose the gate connection. It's probably to do with the merging. Actually, let's see what's going on in the debug here. The num ports is still 1. Ah, yeah, I see. Yeah, there's actually a to-do here for that. Yeah. Oh, yeah, that's right. Yeah. So, that's right. DFS needs to return all of the connected gates. I probably won't ever do it, but I should really do myself a favor and write some safety assertions and run them on every frame while I'm bringing this up. Like making sure that any pointer in one direction is pointed back in the other. Yeah. Okay, let's just do it. Function. Oh, whoops. We'll just call this, I don't know, post condition. Gates don't currently store a coordinate in them. So I guess let's start with the nets. So and in all nets do for C and n.c do but I want it to actually be possible to see what failed. Well, okay, let's say there's more than 20 failures. And I will just put them on the log. Yeah, let's put them on in the, not in the log, in the debug menu. So here we'll do, so if grid of C does not equal n, then debug net equals 1 to number of list do needle and haystack. If v equals n and return I, return nil. Actually, let's just do -1. Or no, let's return false instead of nil. The reason being that I think you can do like that. Oh no, you can't. Okay, in that case, let's just return -1. Net index of. Oh wait, why don't I just do this? Net I points to C but grid wrong. Check net grid. Now we will check net ports for GDo if g.neighbor is not equal n, then g equals p dot parent local genome equals index of g in gates genome port gate wrong. Or G in do. Yeah, I need to save the coordinate. So let's go in here. When we create a gate, we will also do C equals L. That's all we need. If you have, I need a Lua console. I don't want to do it in here. I guess I could. T equals, I don't know, 1, 2, 3. KV in pairs, T. Okay, so now if I set meta table T def and do this again. Oh yeah, okay, great. Yeah, that works. Good. So actually we can do this fairly easily, at least during debugging. Like if you start filling out the grid, this is going to get really slow, but that's okay. So for KV in pairs grid, do check grid object. So if grid of g.c does not equal g, then this is going to be worth it. I just know it's going to be worth it. Equals g dot port I and p dot neighbor. If n dot type equals net, then one case, else if n dot type no, I should make this J. Yeah, right now we don't have invisible connections between gates, so for now I will just debug gate I port J points to bad target. I don't know. Okay. If the type is a net, then if n dot g, if not n dot g of p, then equals index of n in nets points to net And yeah, wrong. How many characters is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So you can fit 32 characters on a screen, and I will know with just this what's going on. So it's okay. Actually, we could do a little better than that. Okay. Let's just call it unimplemented. If v dot type equals blank, then debug like blank at, so here let me put a comment. There shouldn't actually be any pointers to blank objects. This is just the default return from the, come on, index meta method blank at grid. Okay. Else if v.c does not equal, okay, then debug grid k does not point back. Okay, and now let's actually go in here and run the post condition. Let's run it right at the top. Or, well, after we do all the stuff, but syntax error blah. Oh, right. Syntax error. If not blah, then wait, what's going on here? Oops. Syntax error. Line 90. If not blah. I don't get it. I don't get it. What's the problem here? For blah and blah do, for blah and blah do, if then, and the if and the for blah and blah do, if then, and the if and the for, and the first for blah and blah do, if then, bunch of stuff, and for blah equals blah do, if blah equals blah then, if not blah then, and with an else if and an end. I don't get it. What's the problem here? Let's just try and rule out some stuff. Okay, so the problem is not with this. Problem is not with that. I'll be right back. All right, where was I? Trying to figure out where the heck this syntax error is. Still... Is it the fact that I'm using this not here? It can't be. Couldn't be. Oh, okay. So something goes wrong with this line? How is that possible? Do I have like a hidden character from like my weird keyboard? What? What the heck? What am I doing wrong here? Maybe I have like an extra character on this line? Then expected near debug. On line 89. Oh, what the heck? Okay, I guess the syntax checker was just goofing up. There we go. So no post condition problems yet. Let's put in a few wires. Oh, wait. Oh my god, we got tons of crumbs. Grid 1 does not point back. But it shouldn't be pointing back. How come it's not pointing back? What the heck is this? Just all the sound effects. Okay. Oh, duh. v.type equals net. Actually, let's just do it like this. And v.c and not v.c of k, or no, and. Okay, no post conditions. Now let's put a gate in. No post conditions. Let's wire it. No post conditions. So now this post condition, when I merge it, should tell me there's a problem. Yeah, good. Net 1 points to gate 1, port 1, although my port numbers are wrong right now, but gate wrong. Interesting, so the net actually points to the gate, but it's the gate that doesn't point back. Oh yeah, of course. Yeah, because it's got a dangling pointer. Well, it's not dangling because there's garbage collection rather than the thing being freed, but yeah, okay, so yeah, we know we got to do something with the merging. Yeah, the post conditions are probably going to help a lot, so I'm glad I went to the trouble of doing that. Where was I? Yeah, so let's start by beefing up DFS because we have to do that anyway. So let's call this just ends and P's. Ends for nets and P's for ports. Find all chords reachable from the near chord L belong to net N. Returns N's P's, where N's is a list of returns, I don't know, let's call it C chords, where C is a list of chords belonging to N. P is a list of, actually we don't need J. And P is a list of list of gate or junction ports connected to N. Ah! What have I done? Oh no, this is right, yeah. Coordinates, I know. Check for connected gates. If not, C. Okay, so coordinates. Yeah. Yeah, I think this works. Now, where is that? I have that map. I want to use that here, so yoink. And we're going to put that up in the globals. The diff of two linear coords return diff of a, okay, given port linear coord minus neighbor linear coord, return what port number it is. So if I do gate, yeah, so gate minus neighbor So if gate minus neighbor is +1 in the y direction, yeah, I just had my signs backwards. How did I do this before? Okay. So now where was I? So that should fix that, right? This is gate minus whatever. So yeah, that's the right one. And now here in DFS, we have the D right here, so else if grid of NL dot type is a gate phase, then so that means that NL minus L, yeah, okay, so I can just do this. So that gives us the port number. I don't want to mark the gates as seen. We don't recurse on them. We don't technically need to do this here, but it just prevents us from checking the same blank up to 4 times. But actually, yeah, I'll just write it down here. Don't mark gate as seen because we could approach from other directions. Safe because no recursive call in this case. So if grid of nl.port penum equals n, yeah, then I think we just add it to the list of ports. Yeah, actually, because I need neighbor on there too. If p.neighbor equals n, then assert n.g of p. Well, let's just leave it commented. Violated post condition. So now we will do, oh no, I can't do this. I gotta do this. Or is it like this? I have too many variable names. This is getting to be a little bad. Now let's just make sure that everything still works. Oh. No bad post conditions. One, two, three, four, five. 5 nets, no gates, no bad post conditions. I think we're okay. So we didn't break DFS, which is good. Now I think we have everything we need to do the merging there, or not the merging, but the erasing case. Although we have to deal with merging too. Actually, wait a second. How come that didn't work? That should have already been working. To do for each of C's gates, edit them to point to P. Now, I guess I have it listed in here as a to-do. Ah, I see. That's kind of dumb the way I did this. Okay, so make sure port pointers are updated. All of C's gates to point to P, so for I equals 1 to 4 do If all of C's gates to point to P, right? So if G dot port I dot neighbor equals C, then G dot port I dot neighbor now equals P, I think. I should really rename this, but it's a little too late. Oh well. Okay. Let's put in a wire. Let's put in a gate. They're connected. Why are they connected? So net 1 connects to one port. Oh, there's no bad post conditions. I think that was working before, actually, although I'm not sure why. Oh, I know why. Because, yeah. Because I have it on button, not button push. So on the next frame, I was still holding it down for one cycle and it connected them. Oh! Okay. Attempts to index field port a nil value. That's weird. Oh, wait, this is already a port. I don't need to do this. Okay, I take it back. I didn't do this in a dumb way. If G dot neighbor is C, then make it point to P. In fact, this is short enough that we can do this now. I can even do that. All right, now we're cooking with gas. So yeah, what happens here is I press X. Maybe if I do it really fast, I can get it for just one cycle. No, I was holding it for 2 cycles, which meant when I went back to the wire tool because of the previous wire, it immediately connected. But that's actually, that's fine. I think it's fine. Whatever. No bad post conditions. So num gates 1, num ports 1, num ports 1, num ports 0. That's not right. We don't have any bad post conditions. Oh, it's because this isn't connected. Yeah. Actually, that's a little hard to see that it's not connected, but you know. Okay, so first of all, let's do the merge test. No bad post conditions. Now let's erase. This is going to be really put everything through its paces. Oh no! Well, we didn't create any bad post conditions. But it did disconnect it, even though I wouldn't have expected it to. Not to mention, I just realized there's another case here. Here, let me show you. So let's put a gate down. Let's put some wires down. Now if I do, let's do this to move the last wire. If I do this to that, yeah, it doesn't connect it because yeah. So local last wire is adjacent equals this called it a gook, which I may as well do like this. Oh no, actually I'll leave it the way it was. Local wire is neighbor is equal to local wire is adjacent and last wire. Actually, I should probably just call this P is adjacent and P is net. No, actually, P is net neighbor. Yeah, let's call it net neighbor. And then let's also do P is port neighbor. So if P is net neighbor, then that. Do all that. P is net neighbor. Do that business. Okay, so that shouldn't have broken anything. Yeah, I don't know, seems fine. No bad post conditions. Okay. So now, in here, let me just put in a thought here. Actually, this is going to be a to-do, or I don't know where to put this. Drawing wire between gate and net should actually toggle the connection for added convenience. What am I doing on characters? Yeah, it's still fine. Here, this is really dumb though. It's really dumb that I have to code up a separate case. Okay, I have an idea. Ugly hack. To prevent writing a bunch of extra cases, swap P and C if it lets us use an existing code path. So if c.type equals net and p is a port neighbor, then p is net neighbor equals true, neighbor equals false. So let's just see if this randomly like fixes my problem. So now let's place a gate. So previously doing wire to gate works, but now let's do gate to wire. That does not work. Let's put a log statement in here. And let's also change this to button pushed. Wire on wire. Come on. It shouldn't have happened. So we come in here, we went from a gate to oh wait. What am I doing here? This is a gate neighbor. Put down a gate. Now let's wire it to here. Hey, I think that works. No bad post conditions. I think we did it. Oh, but no, we didn't. Shoot. But gate to blank. But, I mean, now if we do it, it'll work. No bad post conditions. Whoa. 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 What just happened? Let's see if we can do an easier test case there. Whoops. How come that happened? What the heck? How come that happened? Swapping P and C because I did wire to gate. So that is wire on gate. Connect gate port. That's correct. Oh, maybe the port number is wrong. Yeah, actually, port number is wrong. Oh, I see, because my differences has to be changed as well. Sign equal S one. Oops. Yeah, because we're all in the same net. Oh yeah, okay. So, but no bad post conditions. We still have a problem of gates to blank. Actually, let's check the log on that. Wire on blank, yeah. If P is gate neighbor, then log connect new net to port. D equals wy times zeros plus slash wx s times lwl minus l pnum equals pnum lut of d G, I know. Local P equals P of Pnum. And G of P equals true. And P dot neighbor equals N. Put down a gate. Now it's connected to, oh my, okay. Table index is nil. Local P equals, oh whoops, this needs to be, wait. I've got some problems with C and P here, yeah. Too many variable names. Now why is that? What am I doing wrong here? Create a new net. If P is gate neighbor, then connect to new port. I think the problem is with this, maybe. LWI times GW plus LWX. That should be right. that. Okay, no. Let's put down a gate and then connect it like so. Now check the log. D equals -1. Okay. Pnum, maybe this is the wrong variable name. Pnum let. -1 should map to 1. Oh. That's why. Okay, great. So we did that. What else are things I know I need to fix? Need to deal, well, I already have it in here, but it's this. But I'll just write anyway, need to deal with adjacent gates, junctions that are implicitly connected. So we don't have gates that connect straight into another gate. But we actually should have enough stuff that we can do some simulation, which is what I've been dying to do this whole time. Am I forgetting anything? I don't think so. All right, here's a question. In the memory map, where's the code saved? Oh, what the heck? So the code, where the heck is the code saved? Anyway, because I need to generate the gate lookup table. So over here in Gourd, where's Gourd? So it's a little strange that we do that. that, then all of these in sequence. I want to generate this. I don't want to write it by hand. It'll be too error prone, hard to debug, and just not fun. So let me change my OBS here. Or maybe I'll do this in Vim so that, and then maybe make the text bigger. Maybe make the text bigger. Okay, that should be fine. Okay, let's change this window capture. Okay, yeah, I think that works. So let's do vim gen gate lut. Do I have syntax highlighted in here? I do. Great, awesome. So now the order of the negators is a little unusual, but so negators equals, oh my goodness, Vim is really friggin' janky, and this is Minty or M-I-N-T-T-Y. It's, I mean, it's certainly a lot better than the Windows command line, but it can be a little goofy sometimes. So 0, 0, 0. This has to all be done by hand. Now, actually, okay, let me fiddle around with okay. So let me put this over here, put that here. Okay, great. Now you can see what I'm doing. So the order is that one, no negators, and then this one, which has a negator on the top and bottom, 1, 0. Then we have this one, which has a negator on both sides. This will go faster once I do this special case here, and then we have one with all 4. Dun, 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 dun. Okay, so now for the rest of these, they're all just circular shifts of each other. So this is, now we go through, this is 1, 0, 0, 0, and so on. Probably isn't like a super slick like Vim way to do this, but like whatever. I don't know Vim. Okay. Oops. And then after this, so we did these 4. Now we have this one, which I think is just, oh, did I get this wrong? No, no, no. I'm doing, yeah, I'm doing port 1, 2, 3, 4. Yeah, so this is actually right. Oops. Come on. Ah, stupid Vim. Okay, now we do the groups of 3. and then that should be it. Yeah, let's just double check that. So if I go to this one here, that is 1011. Uh-oh, I did it wrong somehow. Oh shoot. So this one, let me break these up into groups of 4 so I can see what I'm doing. So this one is right. That's right, that's right. Okay. So this one is right. That's this one down here. This one's right, that one's right, that one's right. What about this one? Oh, I did this in a weird way. This is 1101. It should go here. 1101, followed by 1110, followed by 0111, followed by 1011. Okay, now we got it. Okay. Now, oh, but shoot, do I even have Lua installed on this? Unrecognized option version. Oh, that's right. I always forget about this. Oh my goodness. How do I... Shoot, what is this? Okay. Lua. I think it's this. 5.4. Excellent. That means we have the... This is what I needed. I needed the bit 32. Okay, no errors, so that's working. So now we will do for I equals 0 up to 127. We will do local negators is going to be, oh no, yeah, so I guess I'll put, should I put the negators as the upper bits or the lower bits? I don't think it matters, but let's do it as the upper bits. So b.extract how do you use this function? I gotta look it up here 1 second. Wait, what? Hey, wait a second. What the heck? What's going on here? So in 5.4 they changed it? Now I gotta find it. Man, I really liked that extract function. I mean, I could rewrite it myself. It's not that hard, but... All right, let me just look at the 5.2 manual there, because I'll at least make it have the same arguments. Return, okay, field to field plus width. The default for width is 1. It's just that, like, I want this code to work a little bit more generally if I can. So if not b.extract, then b.extract equals function of value field. What do they call it? They call it n. Field width. Equal mask is equal to b dot. What's left shift in here? L shift. -1. Return b dot the and of b dot r shift and field with mask. That's all there is to it, but it's kind of annoying that they took this out in 5.4. Anywho, so yeah, let's put the negator index in the upper 4 bits, so that means it starts at bit, well, so it starts at bit 3 because we have 3 inputs, so of width 4. Local P0 equals b dot extract. This is fine. Okay. Oh, how come this is now not working? Module bit 32 not found. Man, why did they take that out? Fine, we will write it in the 5.4 style and just move on with our lives. Because like 5.4 added the operators, which is nice. You know, who screwed up my keyboard? Oh my god. Well, the answer is me. I screwed up my keyboard, but anyway. And let's call these P1, P2, P3, just for consistency. Okay? So now, io.write, just a single open bracket. Goal val equals P1. How do you do XOR? Yeah, because they are already using the caret for exponentiation. But actually, I think the tilde is a really smart operator for XOR. Because that's what you write when you're doing a not equal comparison. So yeah, I just really like it. And like in Lua, this is what you write for a not equal comparison, right? So XOR negs of 1. I could have done this in a smarter way, but whatever. P2 XOR negs 2. Oh, wait a second. No, actually, we need to do... This is actually P2, P3, and P4. io.write. String val lim. Now here we'll do if I mod, yeah, just to make it look a little nicer, you know. So we'll do if I mod also the dilim has to come first. And actually I want a tab character. I will do dilim equals comma, but we will have a special case here. If I mod 16 equals 15, then, you know, just to make things look a little nicer, we will do dilim equals, then finally at the end we just do a simple io.write that. All right, let's run it, see what happens. Attempt to index a number value. Oh. Does that seem right? Okay, let's think about this gate here. This should be an OR gate. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, actually, I think that's working. And then here, we have we have this one up here, this weird one. So the only thing that makes it 0 is if the inputs are 1, 0, 1, which is 5. 0, 1, 2, 3, 4, 5. Yeah, it's probably working. Whatever. All right, copy. And paste. Gate value, lookup table. Prevents us needing to do, I don't need to write what it's for. Gatelet equals paste. Huh. Whatever, I'll just fix this. Well, I know, why fix it manually? Like, what would be the point of that when I can just do it in here? There we go. And whatever, good enough. So, yeah, let's just start simulating. I guess I'll do that before the post conditions. So yeah, for each, I mean, I've written down the method here, right? Which is for every driver, currently this is only gates, set the driven net's state to high. Well, only if, okay. And in all nets do, and dot, did I call it state or did I call it value? I guess I don't need this command window anymore in the OBS. Yeah, let's just get rid of it. Okay. So, did I call it state or did I call it value? State. Whatever, I mean, it's fine. For G in all gates do. So state has been computed on previous SymTick. So now we do if G dot state is 1, then yeah, it's okay if we edit the blank. Who cares, right? So we will do G dot port 1. Port 1 is always output. This may edit the state of the blank object, but who cares? Dot state equals 1. Oh, we need to do this before drawing. Or do we? No, we don't. Well, we don't have to. I put draw in the middle, but it's actually okay if we draw as the third step because wait, is it okay if we draw as the third step? Yeah, I think it's okay. Wait, no, we're not drawing as the third step. We're drawing as the first step. Wait, no, are we? I don't know. We're drawing, and then we're drawing as the first step. Is that okay? Yeah, that's okay. Well, it means that on the first frame we're drawing something weird, but no. We have to draw as the second here because in this intermediate state where we do this, the gates and the wires don't make sense. So we do need to draw. So update drivers. First, and then draw. So I'll just write this as compute states for all nets. So we draw them correctly. And then, so try and put a little bit of order in here. Draw nets and cursors, etc. Update state of all, I'll call them delay elements, which includes gates. Oh my goodness, what have I done? Okay. And then finally, just debug logging stuff. So this is now where we will compute the next state of all the gates. For convenience, set blank objects state low, so we don't need to check for it explicitly. And now we will do for G in all gates do. Okay, now, do we have left shifts in Pico 8? SHL. We'll shift left. So local lookup table val starts out as a G dot, what did I call that? Can't remember what I named anything. Here's place gate. I know there's a shortcut key for jumping to the next function. It's alt up and down. Place gate. So what did I call it? Negs. I don't know why I did that. Hey, wait a second. Wait. Is this already correct just by fluke? This 64? Oh, no. I still need to do that, but I can pre-shift it here. Times 16. Do I really want to explain this? +1. This pre-computes the lookup table value for the gate. For the gatelet. No, really like this. Gatelet select. Actually, I should also write this here. Select format is negators P4, P3, P2. Gatelet uses negators as bits 6 down to 3 of select. But in Lua, we need to add 1 for 1 indexing. Pre-compute some of this here to save effort when simulating. Okay, good. So, where was I doing that? G dot megs, what did I call that? G dot, I want to call it something else. I'm going to call it love base lookup value. Okay, now love plus equals G dot port 2 dot state that's G dot port 3 dot state times 2 plus equals G dot port dot state dot neighbor. Dot state times 4. And then simply g.state equals gatelet of lookup value. Done. Easy. We now have simulation. It'll just work on the first try, of course. I want it to work on the first try, but if I really want that, I should think about the code carefully and make sure it'll work rather than just blindly try it and hope for the best. But there's no reason why it wouldn't work. And well, okay, there's lots of reasons why it wouldn't work, but like I could have gotten one of these like indexes wrong, or let's just try it. So we have some, oh, also let me change this. Okay, so let's put a gate. Let's make it, I want to do an oscillator. Oh my god, something went wrong. Oh, okay. I'll have lookup value base. Where is that? Oh. Offset in tiles equals and I actually want to call this TOF. I think it's just a better name anyway. And guess I don't need that. So let's put in, ooh, I think this might be working. No, it's not. No bad post conditions. This should be low, which should make that high. Oh, ugh. Okay, we'll add that to the list of fixed me's. Erasing a net connected, I know. When a net is connected to more than one port on a gate, disconnecting one and incorrectly disconnects the other. But what I want to know now is why I didn't get an oscillator. Maybe it was just oscillating too fast for me to see, although I doubt it. All right, let's put down. Actually, that gate is expected to be 0. Let's, no. So this gate should have a high output, but it doesn't? Why? right, let's start dumping some stuff here. And all gates do, actually, debug gate I debug g.c and debug state equals no. Gate 1 state equals 0. That's not right. State should be 1. At least it's drawing correctly based on the state being 0. That's not right though. Debug state, I don't know, sim gate I p2 equals debug makes lookup value equals lookup value. All right, let's see what this gives us. Lookup value is 17. And if I look at that in my other window, 17. Now why is the lookup value 17? That doesn't make sense. Oh, because it's one indexed. I see. Why is the... So this is... Why is the negs 1? I don't think that's right. Oh, wait a second. Wait. I think I just wrote my script. All right, okay. Well, let me add my script back in here. I know what the problem is. For some reason, I don't know why, but I wrote my script according to Gourd, but I'm using it based on toff. So let's just edit my script to use toff. I don't know what I was thinking. So the only difference is that these three come a little earlier, I think. Right? Let me just look at it, make sure. So, oh, no. It's these that come at the end, I think. Right, so we go 0, 1, 2, 3, yeah. Let's just, I mean, the groups of 4 don't really mean anything anymore, but I may as well keep them. Okay. Where's my lookup table? Oh, wrong tab. I expect this to work now. Okay. Hey! Now we're cooking with gas. Oh, except not though. Well, it's not setting this wire to 1. So, why? Over here in update drivers. Debug. Drive gate I. Oh, a neighbor. Duh. So now we should have an oscillator. Are you ready? Well, we still don't. Okay, P2 0, P3 1, P4 0, that's correct. The negs is 1? Yeah, I think that's right, right? Negs is 1. So, the negs is 1, which means the lookup value is 19. So 1, 2, 3, 16, 17, 18, 19. Wait, shouldn't that be 1? Now hold on a minute. Actually, hold on. I'm looking at this. Wait a second. This is no negators. It's just an OR gate. Everybody's happy. This is just a negator on the output. Oh, I multiplied by 16. I see. Yeah. This should be multiplied by 8. Okay, now we should have an oscillator. So let me just put like a delay, a single gate as a delay element here. Maybe let's put a few, just so it doesn't oscillate like super fast. No. Oh, but we forgot about that. And we need to implement gates being connected back to back, but for now we have to do this. Yep. No, I don't want that. Although this should be oscillating. Oh my god. Ugh. Okay, there's a lot of stuff wrong here. Damn. Oh, all right. So Why is the state 1 here? Like, there's just something like effed up here. Like, now why is P3 marked as being 1? That's not right. Oh, what the heck? Apparently net 1 is still connected to port 3. Or, well, to one of the ports. Okay, man, what the heck? Okay. So things are kind of working, but oh my god, what's going on? Something is dreadfully wrong. Man, it's so frustrating because this is almost working. We got to figure this out. All right, let's see if we can recreate a small. Start with our oscillator. Now, first of all, why didn't that connect to the gate? Hold on. No. So now here, I don't know why it's drawing it as if it's connected to the gate, because it's not, right? Because this net here is only connected to one port, so for some reason the drawing function is judging this. All right, let's first figure that out. Oh yeah, no wonder. So this isn't quite right. DL near DL, yeah, so local pnum equals pnum lut of DL. So DL here is, yeah, this should be right. If n dot port pnum okay, that should at least fix that problem. No. Okay, great. So it doesn't draw disconnected to the gate when it's not connected. Oh my god. What is this? There's something seriously messed up. I think, what the heck, dude? Well, it is nice that on the frame by frame is doing exactly what it should. Kind of. Well, I mean, I don't know what is going on here with my drawing function. It seems to get confused if it's connected to a gate. Alright, hold on. What? What's going on here? I mean, this isn't even connected to the gate, is it? I guess it is. Oh my god. Oh, I know why. It would have connected to the gate because, yeah, I'm using button instead of button push. Okay, so we definitely have an issue here. No. So something goes wrong. But I think, so the net has 3 elements in it. The gate, yeah. So I think it's just the drawing function is messed up. Why? Okay, let's first see what happens if we get rid of that. What? What? What in blazes? Why is that happening? Oops. What? How is this possibly? How does that make any sense? And but I commented this. Oh, because we're breaking. Oh yeah, we shouldn't be breaking. Why am I breaking? All right, I think we fixed that, at least. Okay, good. So now we have a problem where things get disconnected from the gates. When they shouldn't. So this happens when we're erasing a wire, and it's when we do the DFS. I think there's probably something wrong with the DFS. Where is that? Oh yeah, I never even put in the condition, or the code for it. I think I've already got a P in this function. Yeah. Oh my god. G P for gate ports. I don't know, man. So we're dealing with gates for GP and all GP. I know. Report and all GP. Do log. I don't even know what to print here. Gate local genome equals index of port.parent in gats. Oops. Genome dot port dot num. All right, let's do that again and check the log. Also, let me also change this to button P again. Okay, now let's draw our usual test case here. Oops. So now if I go in here and I erase, let's check what happens in the log. Gate 1.3, gate 1.1. Yeah, I think that's right. So, good, actually, that's really good. nn.g of pp equals true and pp.neighbor equals nn. So this should work now. Now if I erase, it still doesn't work. How come that doesn't work? Ports equals 0. Why is that? I just gate 1.1, gate 1.3. So we should be adding that to the new. Ports is here, but why? Oh. Actually, how come that didn't hit the post condition? Local NN, that's the new net. Yeah, actually, how come this doesn't hit the post condition? Did I even check the post condition? What? But this should fire the post condition. Unless something's really wrong. So here, for port null GP, oh, GP RP. So this should definitely hit the post condition because I didn't get rid of this yet, but I'll get rid of it. I want to make sure it hits the post condition, or like it just throws a failure. Oops. Okay. Oh my God. Attempts to index field G. Yeah, okay. We don't even get that far because we need to do this. May as well just do it up here. All right, now the problem should be gone. All right, now if we erase, hey, it stays connected. Cool. So now let's put in some more gates and play around. So cool. So cool. Oh my god, dude. Did you see that? Dude, I think, oh my god, this is amazing. Okay, hold on. Let me change this now. Let's see if we can make a counter. I don't know how hard that'll be. First, let's make a oscillator. I know. So we need one of these. Let's also slow it down a little bit. Just a little. Oh, dude, it's simulating. This is so cool. So pleased. Actually, one thing I want to be able to do. Ah, so cool. So cool. Yeah, so we still have work to do, but all right, now how would I make a T flip-flop sort of thing? I don't know. I gotta think about this. This is actually not easy. I mean, it's probably easy if you already know the solution, but I don't, so, you know. Oh, no. So cool. Man. All right, let's think about this. So, what if I do... So right now I don't have latches, which is making this a lot harder. To do it just in raw gates is actually kind of a challenge. I could make a flip-flop out of gates. Yeah, let's do that. So for that we need a NOR. And we also need another NOR. And they need to wire in. Oh, but I don't have junctions. Shoot, this isn't gonna work. I need junctions to be able to do this. Whoops. Stop. Actually, I might be able to do it without junctions. So this is a NOR. So I think what I need to do is wire this into that and wire the negated version into this. I can't tell what's happening right now. I mean, it's doing something. who knows what. Oh, I think the issue is that this timing is not balanced. This is too fast. I need this to be slower. This is as slow as I can easily make it. So what's happening? Maybe these need to be NAND gates. I forget how to make a... I forget how to do this, honestly. Let's just make this a NAND gate and see what happens. Oh, but this isn't going to preserve the connections, which is kind of annoying. What do I want? I need this one. Well, something's happening here. Don't ask me what. Oh wait, this is not an AND gate. I actually just need this, I think. And then this should actually be the same, I think. Well, honestly, I'm not sure. Oh, wait, no, wait. I think I know what's happening here. So here, this is like the reset input. Oh man, it would be really nice if you could write text. That would be really nice. Anyway, this is like the reset input, and I think this is like the set input. Yeah, so this maintains its state. But if I set it, it didn't work. Now, hold on. I can do this. I should be able to do this. I mean, I'm a hardware designer in my job. I should be able to do this. I need a NOR gate, which is that. So actually, let's check the performance. Oh, dude, we're super good on performance. Anyway, just get a 1 signal here. So if I hit this one, it should force this to 0, and it should stay at 0. And if I hit this one, if I hit this one again, it should still stay at 0. And if I hit this one, should go to 1. Yeah, okay. So I have made an SR latch. Now how do I man, I've just forgotten how to do all of this. So if I want to make a flip-flop, I think the easiest way to do it, you can actually do, I mean, I haven't seen this in a really long time. I'm not going to be able to remember, like I'd have to really sit down and think, but you can make a flip-flop if you have 3 input gates without having to do a, like having to put 2 SR latches back to back. But let's do that for now, since that's how I know how to do it. Now, what's the input? Oh man, I really need to be able to like move stuff around, or at the very least copy and paste so that I could erase the old one. I don't think I'd left myself enough room here to do what I need. So, how does this work? So this is my clock pin, and so I need to be careful in this simulator to balance the timing, which is, well, it's for better or for worse. But that's like you have to do it in Redstone, so. I fail to see what this has achieved. Man, how does this work? I just can't remember. If you plug one SR latch, no, I need basically a clock gator. No, but that's, oh my, it's been so long. So the data, okay. So this is like my data line right here, right? Or actually, so let's say this is, I just want a regular SR latch, and I would wire in my data like this, right? This is where my data would go. And whatever my data is, it gets latched. But the thing is, I don't want, how does this work? I don't want either of these to go high if the clock is high. No, other way around. If the clock is low, I don't want either S or R to go high. So these gates here need to be, so this is low if that is low no matter what. So, man, this is really tough. So I need definitely a negator on the top and a negator here. Because if the top is low, it'll force the square part, the inner part, to be high, which will force the output low. But do I need a negator on the left input? Well, if the top... Yeah, I do need a negator on the left input. I need a negator on these three. And let me just wire this to 1 so I can see what's going on. Okay, great. Yeah, setting S and R at the same time is bad news, I suppose. And we also want the clock to do the same thing on this one. I think we need the same kind of gate here. So we will do this. Let's wire up the clock in here. Oh my goodness. No, but this needs to, right. Because the R needs to be the inverse. So actually I just need the, where is that? I just need, it's oddly hard to find gates in here. Yeah. I got it. So now check this out, right? I really wish I could slow down this clock a little bit. Let's actually slow it down a bit, if I can. I gave myself just enough room. Wait, no, I didn't. All right, let's get rid of this second guy here. I don't need that. And let's give ourselves some extra room. I really want to slow down this clock, so. I'm playing Snake in my head here to figure out where I can put all these gates. I really need to put in those delay elements. I really need to make gates be able to go back to back. Oops. And whoops. So stupid. Okay, now we have a slow clock. So this is a clock signal down here. I try to ignore everything else. Tick, tick, tick. So now this signal here is the latched version of our D signal. So if I erase this, then this wire should go to 0. But it would only do it when the clock strikes 1. Actually, I kind of want the clock to be even slower. As slow as I can make it in the space I have. I also need to implement, let's put this in the list here. Need to implement map scrolling to give us more room. Actually, while I'm here, it might be nice to slow down sim speed, or to even single step ticks. And then of course, let's not forget saving and loading, because if I ever want to play with this circuit again, I'm never going to be able to save it. Well, anyway. It does kind of suck that gates only face to the right, but that's not something I'm going to fix. Like, that's just not getting fixed. Man, it's really neat when you hook it up and just see it, you know. All right, now we have a pretty slow clock. We can squeeze one more gate in here. So I'm going to try and hit this like the minute the clock goes to 0, so that we'll see the delay before the clock latches the new value. I really need like custom inputs and outputs. Yeah, you see that? Cool. So there, we made a D latch. Good for us. Well, I mean, okay, all these extra gates out here are just for making a slower clock. But we made a D latch. It would be nice if we had, I'll write it in the list. Really need easier way to manually input bits. But this is cool, you know? All right, let's push it to GitLab. Okay. I want to save a GIF. How do you save GIFs in Pico 8? I know there's a way to do it. I kind of want to send this to... While the cartridge is running, use Control 8 to start recording a video. You can save a video at any time. It is always recording. Oh, cool. Control 8 simply resets the video starting point. To record more than 8 seconds, use the config command. Interesting. If you're troubleshooting the desktop, try configuring an alternative desktop path in config.txt. Alright, so Control 9 should just save it. What I really want to do is take the output here and negate it and feed it back in here. But the problem is I don't have junctions, so I can't do that. I really need junctions. Alright, and save a little video there so I can send it to my buddy. I don't think that's what I wanted to save. Do I even have a desktop? Oh man. All right, well, let me try that again. So the output is 1. So how's the performance? Performance is really good. I mean, we could crank this up to 60 FPS. Well, actually, it's not really good, come to think of it. Because, like, the map is really big. It's more than just this 16 by 16 thing here, but... Okay. Oh, wait, I don't think that worked. Maybe it did. The clock is still too fast. Okay. No, I did it wrong again. Alright, let's take a look at this. All these random GIFs I've saved. Alright. Sent that to my buddy. No real reason. But he was interested when I mentioned it yesterday, so... Maybe. Anyway. Okay. Well... I accomplished... what I wanted to do. What time is it? Oh my god, it's already 1. I better go.